In this presentation, we're going to look at advanced modeling. And we have advanced modeling concepts for activities and events, which have been the topic of other presentations. And this part of the presentation will look at a few alternatives ways of modeling a particular kind of process. We'll first do this by means of an example. So we're going to look at a process to refund expenses, and we're going to try to express that process logic first with terminate events, then with boundary events, and then with event subprocesses. And then after that, we'll look at a few constructs that are very similar and that can be used to model the same thing, or that have sometimes similar semantics but nevertheless different semantics. And so we're going to look at decisions and rules. We're going to look at communication, external communication by sending and receiving messages, and internal communication. And then finally, we're going to look at different types of automated tasks. So the example process we're going to look at is about reimbursement of expenses. So the process information is that a person has an expense report and files this expense report, and then you have to check if this person has an account. If the employee does not yet have an account, you need to create a new account. Then the report is reviewed for automatic approval. If it's an amount of under $200, it's automatically approved. If it's equal or higher than $200, it requires the approval of the supervisor. The supervisor can reject it, and in that case, the employee will receive a rejection notice by email. If it is approved, the reimbursement goes to the employee's direct deposit bank account. And there are two progress rules. So if no final action has happened in 7 days, then the employee must receive an approval in progress email. And if the request is not finished within 30 days, the process is stopped, so it's aborted, and the employee receives an email cancellation notice and must resubmit the expense report. So here is our basic process with the first attempt to model the desired behavior with terminate events. So you have a start event here, and then you have the happy path, which is at the top of the diagram. And then you have a second parallel path that is actually a time monitoring path. So in the happy path, we first check whether the account exists. If not, we create the account. And if it does exist, we go directly to review for pre-approval. Then we check the amount. If it's lower than $200, we can go to the automatic expense and we can transfer the money to the employee's account. If it needs revision by the supervisor, then the supervisor can decide whether it's approved or not. And if it is approved, we go to the employee's bank account, and here we notify the employee of the rejection. And then we have this parallel path. After 7 days, we send an approval in progress email. And after another 23 days, so that's 30 days in total, we send the cancellation notice. Now we have put everywhere a terminate event rather than putting a normal end event. What is the effect? Well, suppose this process goes very fast and ends here normally. Then by the fact that it's a terminate event, it terminates this parallel branch as well. And in this way, it ensures that the approval in progress email is not sent and that the cancellation notice is not sent. Suppose that this branch takes like 10 days. Then after 10 days, the sent approval in progress email is sent. And then at the 10th day, here you have the terminate event. So this branch is cancelled. This mail was sent, but this second cancellation notice was never sent. If this path takes more than 30 days, what happens is that after 7 days, you will send an approval in progress email. After another 23 days, you will send a cancellation notice, and then you have the terminate event, and the terminate event will abort this top part of the process. So it nicely works and it does what we expect it to do. The second attempt, or the second proposal to model this process, is to put a normal flow in a subprocess. This subprocess is captured in a box so that we can use it as scope delimitation for two events, and it are interrupting events and a non-interrupting event. The non-interrupting event is after 7 days, so it sends the approval in progress email and it doesn't stop the entire process. But then after 30 days you have an interrupting event that interrupts this entire normal path and sends the cancellation notice. So you obtain the same event, the same logic, but you have, say, a better distinction between, on the one hand, the normal flow and then the interruptions that can happen, or the things that happen according to certain timings on top of this normal flow. The third proposal is to capture the logic of the non-interrupting and the interrupting event with event subprocesses. So again, you have here the normal flow, which is now modeled with normal end events, and you have two event subprocesses. After 7 days, this subprocess will be triggered. It's non-interrupting, so the basic process will continue. After 30 days, this event subprocess will be triggered and it will interrupt the process because it's a full line. So you have the same logic. So you see that the same process logic can be formulated in 3 different ways. My personal preference is the last one. I think this is the most understandable and clear way of representing that process. Let's now look at a few constructs that are similar but nevertheless different. So the first topic we deal with is the issue of decision and rules. Processes can contain a lot of rules, and you can also have a more declarative approach to business processes where you only formulate rules. So to a certain extent, you can say that processes and rules are complementary. They each allow to model processes from a different perspective, and they can also complement each other. But however, there are no guidelines on how to combine the two paradigms in a good way. And there is also little support for rules in BPMN, which makes the combination a bit harder. Ideally, business rules should be defined independently of the process in which they are used. So that's one of the reasons why you don't want your rules to be embedded in your business process. It is because these rules are general and they have to be observed in different processes. So when you change the rule, you would like that all the processes where this rule has to be observed are changed or change their behavior accordingly. This would be a reason to model the rules outside your business processes. Now in BPMN you have different places where you can put rules. First, you have your gateways, your OR and AND gateways with the conditions on the arrows, especially for the OR gateways, contain a number of rules. These should be considered as routing rules, and what is very important, these are process-specific rules. So this is not a good place to put a rule that is process-independent, because it's always process-specific, and so if this rule appears in, say, 30 processes and it changes, you have to change it in 30 different places. A way to have process-independent rules is to make use of the business rule task. This is a task that is actually a decision service that you can call at a particular point in the process. And it allows you to call upon a service that is outside the process and where rules are checked. And this task can return a value true or false. And so after the business rule task, you can put a gateway and you can use that gateway to test the outcome of the decision process and then route your process in the right direction. So for example, suppose you have some application or a file that needs to be approved. Rather than putting lots of gateways into your process that test for the different conditions upon which you can approve this application, for example, it's better to have a business rule task like review application for approval, and then have after your business rule task a gateway approved true or false, and route then the process depending on the approval having been obtained or not. And a final thing you can have is a conditional event. And this conditional event can be used to signal when a particular condition has become true. And typically that will be by observing certain data values and having a test on these data values. So if we put everything together, sending a message is like a task or a message sent event. When you wait for a message, you can have a receive task or a catching message intermediate event. You wait for a message, it's not the same as catching a message on the boundary of a task, because then you're not actively waiting, you're doing something, and while you're doing that, all of a sudden a message arrives. So you are like kind of busy, and the message might arrive while you're doing something, but if the message arrives at another point in time, you don't let yourself be interrupted by that message. And when you're waiting for a message but you want to model the timeout, then you use the event-based gateway, and the gateway acts like an XOR, a choice between waiting for the message or a certain deadline has been reached, and then you proceed with something else. Let's look at the issue of send tasks more in particular. So a send task is a simple task that is designed to send a message to an external participant, external relative to the process. Once the message has been sent, the task is completed. If you look at the definition, you might think, well, actually that's the same as a send message event, an intermediate send message event. You have to remember that, okay, in both cases, what is the same is that a message means that there is communication between the process and an outside entity, so that's the same for both. But what is different is that an event has no duration and a task typically does have a duration. So when the composing, the message is very simple and doesn't take a time to compose, then you can use a message event. If it's like a very elaborate process or task to compose the message, a task would probably be more appropriate. If you have the possibility of a message communication but not a certainty of it, then you need to use a user task. So as a general advice, you can say that you use user tasks for human communication, so to symbolize a sending of an email, a fax, or phoning in particular, and when you're not sure that there is a message that will actually be sent. And you can always use a send message throwing event for machine-to-machine communication, especially when it's about very simple messages. You don't use message task or message events for communication within a process. For communication between lanes, you simply use a sequence arrows. So when you have, like in the little example here, task 4 is in lane 2 and task 5 is in lane 3, well, you have a sequence, and it actually means that immediately as task 4 is finished, task 5 will be put on the to-do list of the person that corresponds with lane 3. So it's not necessary to have a send task just to symbolize that the work is passed on to the next person. This happens automatically and is kind of part of the functionality of a business process engine. If you have internal communication with a person that is maybe not modeled actively in the process, and of a person that doesn't have a work list, you can simply use a task like notify your manager or send email to a particular person. Then we have also different kinds of automated tasks. In particular, we have service task and script task. Difference is that a script task is executed on the process engine itself, whereas a service task is an automated task that is executed by something else than the process engine. Typically, it is processed by an application, and the application will be invoked by the process engine. You will use a service task when you want to have a synchronous call to a service. It means that the process will wait until the service has completed and sends a reply. So you don't use that for long-running processes. An asynchronous service request means that you just like trigger this outside application and want to launch it, but you're not going to wait until it has performed to do other things in the meantime. So then in that case, you model the service as a black box pool and you send a message to it to indicate that it can start. So here you have the example. So here your process 1, you have a message and you send this message to this service provider, and this might, for example, mean that the service provider can start working. And then maybe at a certain point in time you will receive a response or an error. Then you can use this event-based gateway to treat the response or the error. And between this and this gateway you can put a number of tasks. Here you have a normal task, and here is a service task where you don't model the communication with the application. You just invoke the application, wait until it finishes, and then proceeds. So here you see it depicted differently. This is calling a short-running service and just waiting until that service is finished. This is like sending a request for a long-running service. You can do lots of things, and then at a certain point in time you will receive an answer from that running service, and you can do something different. These two things could also be modeled by means of intermediate events.